For centuries, scientists believed that matter could disappear, transform mysteriously, or be created from nothing. Burning seemed to destroy substances, metals appeared to gain properties when heated, and no one could clearly explain where matter actually went. Then a single idea changed science forever. The realization that matter is never lost, only transformed. This is the Learning Studio, where we don't memorize discoveries, we understand why they reshaped the world. And in this chemistry series, we're tracing how chemistry became a true science, built on measurement, logic, and laws that still govern everything around us today. Most people think Lavoisier's revolution in chemistry is just a historical footnote, but in reality, it controls every chemical process you rely on, from cooking food to producing fuel and medicine. For example, when you burn a candle and notice that wax disappears while heat and light are released, it looks like matter is vanishing. But what's actually happening is far more precise. The wax is reacting with oxygen and rearranging into new substances, not disappearing at all. At the molecular level, the mechanism is simple yet revolutionary. Atoms are not destroyed or created during chemical reactions, they are rearranged. Every particle that goes into a reaction comes out in a different form, but the total amount of matter remains constant. This principle is what scientists formally define as the law of conservation of mass, and it is the foundation of all modern chemistry. This idea became undeniable through the work of Antoine Lavoisier, who refused to rely on assumptions and instead weighed substances before and after reactions with extreme precision. By measuring gases, solids, and liquids during combustion, he proved that mass remained constant, even when substances appeared to vanish. His experiments shattered older theories like phlogiston and replaced speculation with measurement. But Lavoisier didn't stop there. He transformed chemistry by introducing systematic chemical naming, clear definitions of elements and compounds, and the idea that chemistry must be quantitative rather than descriptive. In doing so, he turned chemistry from a collection of observations into a science governed by universal laws, just like physics. The impact of this revolution extends far beyond the laboratory. The conservation of mass underpins chemical equations, industrial manufacturing, pharmaceutical production, environmental monitoring, and even modern energy systems. Without Lavoisier's insight, we could not calculate reactions, design medicines, scale chemical processes, or model the behavior of matter accurately. And once we accept that matter is conserved and reactions are governed by measurable laws, a deeper question naturally emerges. If matter is rearranged rather than destroyed, then what are the basic building blocks being rearranged in the first place? That question takes us directly into the next episode, where we explore why everything in the universe is made of atoms, the idea that truly unlocked chemistry's inner structure.